Hello everyone, in the previous video I showed how to build full adder using relays and logic gates and how logic gates can remember data. Let's abstract away from the complexity and let's make our schema a little bit smaller. As I said before, in our Logisim, in our program, we already have this element like adder, and this element has bits, like the number of bits. Yeah, here we used only one bit just for showing you how the circuit works. But now I want to save our working area and show you that the same adder can work only with this one small element. Let me show you. Okay, what we have now? Currently we have the same adder, and this adder does the same job as this schema, yeah, but we save a lot of space. Yeah, then we can remove this whole schema and left only the small variant of this adder. Yeah, also as we remember, we have our 1 byte memory because we have 8 bits. Yeah, we can save these bits. That's why we have 1 byte memory. But for this memory, we are using the element what call it the flip-flop, and this element doesn't have number of bits here, but we can use element what call it register. Yeah, this register can do the same work. Let me show you also. Yeah, this register can do the same work as I said, like this our memory. Yeah, and we have in this register we have a number of bits here. That's why we can use this register instead of this big circle. This is first part of programming. It's actually not only programming by any design on any engineering. Yeah, some complex part could be encapsulate in some small part, and we can like go we can abstract away from the complexity and use some small parts. Yeah, because we already know that these gates, this element can be created from gates, and the gates can be created from relays, etc. Okay, now we have let me remove these things. Now we have very small diagram, and we can connect our full adder with our 1 byte memory. Yeah, but before we do this, I just want to add some probe here, so we don't need to mentally convert numbers from binary to decimal. That's why I choose decimal here and here. This is our memory. Yeah, and what I'm going to do here, we have our output from our adder. Yeah, we have some result here, and we can save this result as a data in our memory. Let's remove this input, and our output of our adder will be the input of data in our memory. That's how we can sum two numbers like 1 and 1, 2. Yeah, 2 it's our output, and we can click save this to the memory, and we can add additional number like 15 plus 1, 16, and save it. Okay, now it works and we can save something, but we can save a result. Yeah, but what I want to do also, I want to get this number from the memory and put as input to our adder. Then we can add a lot of numbers just for using our memory. Let me show you what I want to say. I remove this connection, yeah, this second number, and just enter the output of our memory as a second input to our adder. Now we have 3 and 4, it's a 7, but we can save this, yeah, and what we see now, we save 7 to our memory. That's why 7 it's now a second number of the input, and that's why 3 plus 7, 10, yeah. Then we can change this number like some random number, 25 plus 7, 32, and we can save this to here. That's how we can calculate our transaction. As we remember Tom and Harry, we want to calculate our income, like a new number, and we can add this number with this number, and we again need to add some additional transaction, and save it. And if we click save, we just increase the number, yeah, the first number 3 and the second from the memory, and the result, yeah, that's how it works now. The problems here actually that we always take a second number from the memory. But what I want to do, I want to add some switch here, like, you know, like the first operation will be from the this input, and the next operations can be from our memory. And also we have the problem that I need to press a button. People is lazy. People don't want to do anything. They press buttons, etc. People want that artificial intelligence will work instead of them. Yeah, that's why, as we lazy, we need to create something for press a button. Yeah, and we need to understand how we can create this switch between these two inputs. For understanding this switch, I will show you the next schema with gates. I will add a couple of gates here, the AND gate. Okay, let's see how these circles work. Yeah, if I press 1, I see the 1 as output. Yeah, if I press 1 here, I don't see this one as output. Yeah, but if I click here, I see this input. This combination of gates, call it multiplexer. A multiplexer takes several inputs, uses address lines to choose one and send it to the output. Let's call them like input 0 and input 1. That means this is 0 address, this is first address. And if we press 0 here, this is our address, we have 0, 0, and we select 0 address. That means currently our output will be taken from here. And if we press first address, then this output, this input will be taken and will work as output. Go in our tradition, Logisim already has the multiplexer element, and this element does the same job as our gates. Let me show you again. Yeah, we can have 4 output or 4 input, and we can have address here, and the result, the address line. Yeah, but here the address line currently has 2 bits. Yeah, because we have not 2 input but 4. Yeah, and I select 1, this is 0 address, it's here. I select here, I don't see anything because I need to switch the first address. I select here, I need to switch the second address, yeah. And also, if I try to do here, I need to select the fourth, yeah, because it's a 4. That's how multiplexer works. And let's use this multiplexer in our schema here, for switch between these two inputs. And the address input, it's 1 bit, because it's 0 or 1. Yeah, 0 selected the first input, like the second input of the full adder. Yeah, and if I press 1, it will be from the memory. That's how it should work. Let's add 1 plus 1 and save it to memory. It's 2. And now we can switch and do operation from the memory, and we can add, yeah, first number 1 with 4, with 5, with 6, etc. But then we can switch back and add some additional number like 16 plus 1 and save this to memory, 16, and then again switch to our memory, and then again click some additional. Now with multiplexer, what we can do, we can create a list of transactions, and we can add all of them using just a button. Yeah, let's try to do this. But first of all, we need to fix our button click problem. For this, we need to understand one more logic gates combination. Let me show you. I will put for the flip-flop in some complex combinations. 4 will do in. Okay guys, this combination, what this combination can do. If I start pressing the button, something started happening. If you don't understand what is happening now, let me show you in this case. I will add the probe here and I will set this as a decimal and we can see what is going on. I press the button and I see the increment things. Like something happens and the application, like our schema, tried to calculate from 0 to 15 actually, yeah? But as far as we click the buttons, we can check one more combination of relay. If we look at this combination of relay, we can see these things. Like if I close this switch, yeah, the relay start working because circuit will be closed. The relay start working, but magnetic things happens and this switch open it. And as this switch open it, the relay stop working and this switch closed back. And what is going on? It will be like a drilling bells. It works like something would switch from 0 to 1 couple of times, like 0 1 0 1 0 1. It's a generator of some something. Yeah, generator of let me find the right word actually. That's actually a clock generator. The clock generator produced a regular clock signal for the circuits. Yeah, and in our tradition, our Logisim actually has this element, and we can simulate this. We can enable simulation, and we can choose the frequency. The frequency currently will be 1 Hz. Okay, the unit that measures how many times something changes per second is called Hertz. Yeah, that's why our frequency currently is 1 Hz, and this generator can work. And now our circuits can calculate from 0 to 15 actually. Now we can use it, but let's abstract away from the complexity and check that Logisim already have counter thing. This element will do the same work as our generator and take not a lot of place. Yeah, actually it's the same thing, and we can say the same results. And our counter works like that. Let's go back to our schema and create some device. Okay, what I'm going to do now, I'm going to create some list of inputs. We can imagine this is our income, what we want to calculate from the previous video, yeah, and from our general idea, yeah, to calculate some income. And we have some list of inputs. Maybe it's list of successful transactions. Let's create 8 of them. 1, 2, 3, 4, 5, 6, 8. Cool. Then we can use multiplexer here with 3 and data bit will 8. We'll do this very carefully. This is an electrical thing to be careful. Okay, let me add some labels here, like input 0, input 1, 2, 4, 5, 6, 7. And our output will be go to the element other, and we will see results here, but the second output will be our register. Let's add the register. Okay, we can save the result into our register, and as we remember, we press this button here. Yeah, currently we can use the generator, like the clock. If we can use the clock here, we do not need to press the button actually. Yeah, but this is not all. Also, we need to have our counter here, and the counter will change the address line. Let's put 3 here, and let's also attach counter to this generator. Let's add the output as a result, put some probe to see the actual result. It will be decimal, and let's set up some starting numbers like 1, 1, maybe it will be 2, something like that. This is the numbers, and this system will take first number, will save it in the memory, the result, then took the second, save the third one, etc. And we can try to see how it works if we enable ticking, yeah, and we see that something happens. These things, this combination of the element, we'll call it actually the read-only memory, because we have the memory and we can read this memory. This things is a counter, yeah, and this counter just go through the all addresses, like first address, second address, third address, etc. That's why the counter works like that. And this memory, using this generator, just can save some data in memory, yeah. And we now read memory element by element and save it. Let's also see how demultiplexer work and how random access memory work. Yeah, if multiplexer works like this, yeah, multiplexer receives couple of inputs and using address can select what input should be on the output. The multiplexer work the same but in different way, yeah. In 4, it took only one input, yeah, and using address it can select what output should be, like what output should work for this input, yeah. Let's do these things. Let's add 8-bit memory here. Yeah, I'm set the virus, and as you see, this is not a virus of data, yeah, this is virus of synchronization. That means when I select some address here and press some input here, it will be my switch type of register, what actually register I need to use, yeah, for saving something or for reading. Let's do this again. Okay, now let's add the input, and I will put it like that. This is needed for the input actually. I can do this one, and we can connect all data to one input, 8 bits, and we can have the address. We can add button here and the address here, 2, that's 1, and the output, yeah. And what we have now, we can we can add some number, we can set some number on the input, we can choose the address, like the 0 address, and we can save this to our memory here, yeah. We can change the input, like change the number, we can select another address, and we can save another value here, and we can see this value here. That means in this cell of memory we save something, and we can read something from here, and we can write something here. That's why it's a random access memory, because we can select some address and just save this data from input to this memory, to this address. Yes, and this is actually operational memory, yeah, of any device, of your machine or of your home computer, of your phone. And we already have this component here, and this component called RAM, and took not a lot of space. But we will see how it works in the next video, because first of all we need to understand one more number system. See you next time.